Do you know if this video is being recommended to you based on your liking and preferences? That is basically an application of machine learning. Machine learning itself is so deeply involved into our lives, and it is a constantly evolving field. In this video, you'll find basic understanding of machine learning, the overall process of training and testing out a typical machine learning algorithm, and basic categories of machine learning algorithms. So let's get into it, shall we? So what is basically machine learning? Machine learning is an application of artificial intelligence which enable a machine to learn from experiences without explicitly programming it to do so. That is basically a machine learns from the data which is fed into it. It develops its own knowledge base, and then that knowledge base could be used for different applications. Let's consider an example. Service providers like YouTube, Netflix, Amazon, Zomato, Uber. The moment you start using their services, they're going to start building up your specific profile data sets. And the more you consume their services, that is the more media and movies you watch, the more food you order, the different range of products you shop for, your profile data sets only gets much more rich, much more mature, and much more detailed. Now, if you run a machine learning algorithm on such detailed dataset, chances are that machine learning algorithm will know a lot more information about you, much more than you do probably yourself. And knowing such level of detailed and intricate information about you, it will start recommending you movies and media which you probably might like. It will start recommending you products which you probably didn't know you needed and desired. So it goes one step further in deciding the services and applications for you without making you actually search for it. And that's just one application of machine learning. That is recommendation system. Image recognition, speech recognition, predictions, medical data, personal assistance, sentiment analysis, search engines, self-driving cars. These are all applications of machine learning. And machine learning has also started evolving crazy in the field of creative arts. We discussed that in some sense in one of our other video. You can go ahead and check that out. It's not like the concept of machine learning is new. The notion of machine learning came into picture long back in 1943 when a logician, Walter Pitts, and a neuroscientist, Warren McCulloch, they came together and attempted to mathematically model the logical processes which happen in the absolute marvel, which is our human brain. They tried to mathematically map out how logically a human brain works through the concept of neurons and neural network. Then came Alan Turing, who is also considered as the father of the modern computer science. He came up with something called Universal Turing Machine, which laid out the foundations of the computers we use today. So definitely a pretty significant figure. You can check this pretty brilliant movie made about him, Imitation Game. He also came with Turing test to evaluate how intelligent a machine is or not. The point is, a lot of amazing people ranging from researchers, mathematicians, statisticians, logicians, philosophers, neuropsychologists, and many more. They have all contributed so extensively in laying out the foundations of machine learning as we know it. So a huge shout out of respect for all them. The only reason machine learning has started booming up in the past decade or so on a more practical level, it's because of the advancement of the kind of computational power which is more easily available these days for any machine learning algorithm to execute. And this advancement of the computational power, that again was predicted by Alan Moore through his Moore's law, which states that the number of transistors available on a chip to perform computations, they are going to double each year. And he stated this law long back in 1965. It's kind of debatable if this law still stands true in year 2022, but many do believe that it still does. Enough about the history and the stories part. The point is, the field of machine learning is really interesting and it is all around us. So I think we should have at least a basic level of understanding as to how these applications actually work. That being said, let's move to our next section. Let's understand the overall process as to how to train a machine to learn something. Data is the crucial part of any machine learning algorithm. That is what the machine is going to learn from. Here are some amazing sites offering free datasets for you to experiment with. I'll be sharing the link for those in the description. You can also collect data from any website using the concept of web scraping in Python. The data itself could be in any file, be it Excel, text, PDF, or they could be extracted from the databases themselves like SQL and Oracle. Once you have all the data in place, it's time to perform some level of pre-processing on it. That is, structuring the unstructured data, cleaning up data for any missing values, fixing or eliminating all the data errors, dealing with the outliers, and converting the data to a standard format which a machine learning algorithm is going to expect. And then we split the overall dataset into two parts, that is the training part and the testing part. Now that we have our data sorted, we first need to understand what kind of learning could be done through that data. So it's important for us to understand what the data means in the first place. We can go ahead and use some data visualization to get some graphs and charts out of it to get a good idea about what that data means. What kind of different trends and patterns are present in that data. For example, consider a simple data set for housing prices. Now you're going to have columns like the number of rooms, the number of floors, the total area, the locality, and then you'll have the final column, that is the price of the house. Now if you visualize this data through some graphs and charts, it will give you a fair idea about how a parameter is affecting the overall price. For example, how the number of rooms in a house is affecting the price of the house. So you get that kind of correlation at a glance while performing some visualization on the data. And then you can start asking questions as to what could be done using that data. This will give you the initial point to start working on. Now that we have the problem statement, it's time to choose the algorithm. It could be classification, it could be clustering, it could be prediction. We will be understanding these algorithms in detail in the next section and on a much more practical level in the part 2 of this video. Now that we know what kind of algorithm we need to use, then comes the interesting part, that is teaching the machine part. Remember, we split the dataset into two parts, that is training and testing. The algorithm is going to take the training dataset as the input. It's going to learn, it's going to train itself from it. There are actually amazing libraries for different algorithms you can use to perform the training part. Once the training is complete, we need to evaluate how well the machine has learned from the data. For that, we use the testing dataset. There are metrics provided by the libraries we use for training. They provide us with the accuracy score. That will help us evaluate the overall training process. If we get a lower accuracy score, we can go ahead and change the dimensionality of data. We can go ahead and change the parameters. We can go ahead and tweak the parameters of the machine learning algorithm in order to increase the overall accuracy. And once you're satisfied with the score, the application is good to go. So primarily there are three categories of machine learning algorithm. The first one is supervised machine learning. In this type of algorithm, the machine needs external supervision to learn from the data. That is, we provide the algorithm with the examples for it to learn with. You have the clear set of inputs and outputs defined, and this kind of dataset is called as labeled dataset. So the machine has the clear picture of this is the input and this is the output. It is going to perform its training on that part, and once the training is completed, you can go ahead and test it out using the testing dataset to see how well it has learned, how well it is predicting the output values. Let's consider an example to understand it better. Prediction of housing prices. Again, you have the dataset which has the columns like the number of rooms, the number of bedrooms, the area, and you have the output as the price of the house. Now consider you have 1,000 rows of 1,000 houses, and you feed this data to this supervised machine learning algorithm. It's going to learn from this. It's going to try to understand how a typical parameter like say for example the number of rooms, how a parameter like number of rooms is going to affect the overall pricing of the house. So it tries to draw that relation between these different input and output features, and once the training is completed, you can try testing it out using feeding it a data input like if this is the total number of rooms in the house, if this is the total number of floors for the house, what could be the price of the house? And based on this input, based on its learning, based on its knowledge base, it's going to predict some value for it. So that's how this algorithm functions. Classification and regression are two primary examples of supervised learning. The next category is unsupervised learning. The machine doesn't need any external supervision when it comes to this kind of algorithm. It is going to work with unlabeled and unstructured data, and it is going to derive some patterns and correlations between the data points. And there is no predefined output in this case. It is going to try to get some useful insights from this huge volume of data with multiple data points. Let's understand it through an example. Identifying different customer segments for targeted advertisements. That is understanding a general trend of shopping. For example, we could have a data set which contains data of consumers like their age, their gender, their income. Based on these data points for multiple customers, it's going to cluster different customers together which share the common shopping pattern. So clustering is basically one of the example of unsupervised machine learning algorithm. The third type of machine learning algorithm is reinforcement learning. There is again no supervision here. In this algorithm, there is a concept of agent which is going to interact with its surroundings, perform from a definitive set of actions, and it is going to learn through feedback. That is, the agent is rewarded for a correct move and it is punished for a wrong one. In a sense, it's a trial and error kind of learning which happens. Consider an example like teaching how to play chess. The algorithm is provided with the set of actions, set of rules, set of states, and the model is going to learn performing actions through trial and error. So to sum it up, these are the primary categories of machine learning algorithm, and now we are good to dive a little deeper into the algorithms themselves and how they are implemented on a practical level. That brings us to the ending of the part 1 of this video. This was meant to give a short summary, a short revision of sorts about the different machine learning algorithm, how the process of training and testing is performed in a more of a theoretical way. So that's all for this one. I really do hope you found the video useful and helpful and interesting. Till I see you again in the next one. Cheers!